Okay, let's imagine that you've got a wire, and the wire's got a certain length to it, right? And it's got a certain cross-sectional area. So a thicker wire would have a bigger cross-sectional area, and a thinner, a smaller, right? And then, of course, the question is, what does the resistance of this wire depend on, right? You might imagine that the longer the wire is, the bigger the resistance, right? So resistance is going to be proportional to the length of the wire, right? And then the bigger the wire is, maybe the less the resistance is, right? So a simple formula would be like that, and then we just need like a constant to make it all work. So what we do is this. Okay. Whoa, look at that. Okay, so this is our formula, right? This is the resistance of the wire. The longer the wire is, the longer the wire is, the bigger the resistance. The bigger the area, the less the resistance. And then the resistivity is a constant that makes this all work, right? Notice that the resistivity is in ohm meters, because ultimately you're going to have what? Ohm meters, right, times meters divided by square meters, right? Ultimately, the resistance will be in just ohms, because the meters all cancel out, right? So basically, this resistivity right here is the thing that doesn't depend on the dimensions of the wire, right? It's just the inherent resistance of the material, okay? Here are some resistivities. I just got these out of the textbook. And notice that they're 20 degrees Celsius, right? Wire, as the metal heats up, the atoms move more and more, and this interferes with the motion of the electrons, and so the resistance typically will increase with metal wires anyway. And other things have, like semiconductors have a different property. I believe when they heat up, the resistivity decreases or something like that, called thermal runaway. But anyway, notice that they're all of these are quite small, and that's because of what they would be the resistance of a wire that's a meter long and has a square meter of cross-sectional area, right? It would be a very small resistance because it's such a huge wire, right? But anyway, you can look at these things, and so here's things that are considered to be good resistors, or I'm sorry, good conductors have a small resistivity. So this is like what the opposite of conductivity or something, right? Notice that silver is the very best conductor. Copper is better than gold, which is interesting, right? They plate conductors with gold in computers, not because of the conductivity, but because of the gold doesn't corrode, so the connection always stays really good. Aluminium is fairly good. Tungsten, not so good, right? Although resistance is, they make light bulb filaments out of tungsten. Notice nichrome wire is like off the charts, right? 10 times, 100 times more than some other things, right? Anyway, let's do an example problem here, right? A steel wire is 2.7 meters long, has a resistance, so the length is 2.7 meters, right? The resistance is 7.3 ohms, right? And then we want to know the diameter, right? Well, the diameter is twice the radius, right? And the area will be what, pi r squared. We're assuming this is a cylindrical wire, like most wire, right? Okay, so ultimately we're going to say the resistivity is equal to, or I'm sorry, the resistance is equal to the resistivity, and this is, we'll just use the one for iron for steel, hope that it works, right? Times the length of the wire over the area. So I think what we can do is we can solve for the area. The area will be rho L over the resistance, right? So that'll be 9.71 ohm meters times, how long is it? 2.7 meters divided by 7.3 ohms. And it looks good. It looks like we're going to end up with square meters here. So let's just try this. Okay. Oh, 9.71 times 10 to the minus 8th, right? Let's put that in there, right? Can't miss the 10 to the minus 8th, right? 9.71 e minus 8 times 2.7 divided by 7.3. And apparently I'm Not typing the right thing yet, so let's, oh, there we go. Let's get rid of that. Okay. Oh, there we go. Okay. So now we're cooking with gas. So we've got 3.59. I'll say 591 E minus 8 square meters, right? And then that's going to equal pi r squared. So what am I going to do? I guess I'm going to divide that by pi. And then I'm going to take the square root of that. And I've got that my radius is 1.069 times 10 to the minus 4th meters. But we want to know the diameter, so I'm going to multiply by 2. And I get, so this is the diameter, twice the radius, right, is 2.138 times 10 to the minus 4th meters, or 0.2138 millimeters, right? Because a millimeter is 10 to the minus 3rd. So it looks like we got the right answer. All right. Anyway, pretty simple formula, not terribly difficult. Kind of cool, though. Now you can calculate the resistance of any wire based on the material it's made out of, right? All right. I'm going to do some more examples here in the whiteboards.